Guten Tag. Pardon my German. Hallo, ich bin Alek. Ich arbeite bei Applaus in Warschau. Aber wir haben auch ein Büro hier in Berlin. So if you are interested in talking with us about our work for Applaus or application quality, because this is what we are working at Applaus, catch us after my presentation during the coffee breaks. So you already know that I'm Alek, and I go by Pelotas Plus on the internet. My presentation is about inferiority complex, about mind complex, and also about the gap between us, mortal developers, and rockstar developers from Square or Google. I will try to find the answer. Is the gap big, or maybe we are at their level? I also learned that there is the inferiority complex could be also called impositor syndrome, and actually there is a wiki page about that. So if you are curious what's this impositor syndrome or the inferiority complex actually is, go to the wiki and see that. The story about the presentation is that I made a presentation a year ago during droidcon in Krakow about what's new in Lollipop. Back then it was a presentation about new APIs in the Lollipop, and there are, I guess, better suited guys to do that. For instance, Wojtek is sitting there from Google. So to learn what's new in Lollipop or the new release, which is, I think, called Macadamia Nut Cake, right? It's official name, MNC, Macadamia Nut Cake. Of course, Wojtek won't tell you that, but that's the new name. So back then, my presentation was about new APIs and whatnot, but as always, the devil is in the detail, and I learned from the guy, Alenkov, he goes by Captain Petko on the Twitter. I learned that it's also very interesting to see how the API works from the other side, under the hood. So back then I made the presentation about new APIs, then thought that maybe I will look how they work, how the guys from Google wrote the code. So this presentation here will be a bit technical later on, and hopefully you will find some motivation as well. And at the end, we will find the answer, are we all rockstar developers or not? I will start with the disclaimer. Disclaimer is very important because, first of all, the disclaimer started with a joke, but at the end, I was approached by a guy from Google who said that thanks to the disclaimer, he understood that I'm not smart that is making fun of other developers, not showing his own code. I'm just commenting Google code because it's written in Java, because it's open source, and because I'm working with Android platform. And there is no pun intended here. I'm not making fun of Google developers because I don't have anything against Google. I make living thanks to their technologies. I don't want to diminish their achievements and say anything bad about their developers. And in the end, it's not like I was recruited by Google. I sent them my CV and they turned me down. So there is no bad blood between me and the Google, right? So first of all, how I got my inferiority complex. So I attend various conferences. In this case, actually, it was an Apple conference, but I read a lot and I see that other developers are creating lots of new stuff. For instance, iOS 8 give us 4,000 of new APIs. So in a year, they created lots of new stuff, and I in a year, closed like maybe 20 tickets in Jira. So I'm not so a potent developer, so I always thought they are better developers than me, creating more stuff, writing more blog posts, creating videos, or creating new libraries. So I was reading about that. I was seeing that there are lots of very new and powerful, interesting stuff like material design, new Bluetooth stacks. And I thought that, oh shit, I'm not a rockstar, right? Of course, there is also very strong pressure from the Android Weekly. Every week, we receive an email, right, with like 10 new blog posts, 20 new libraries. And sometimes even you see that your own friends are creating those awesome libraries and you are not making, so it's like, for me it was like, oh shit, I'm not so rockstar. So I thought that maybe I would do something about that. So instead of creating libraries, I started making presentations. So it's one of the solutions. Another one is to take a look at the code, and you will see if it's not that hard. So let's go to the Lollipop because it's in the title of the presentation. But it of course applies to other versions of Android, right? Let's start and look at the changes in the Lollipop, some changes, and try to compare ourselves if it's in our range, right? If it's possible for us to create such changes. Material design, huge thing. I think it's you have to be Rockstar developer to create material design, right? Web view updated via Play Store. You have to be Google to do that because it's a part of the platform for sure. Also, it's quite a technical challenge. Also quite interesting, full disk encryption, so it's super hard. You have to be security geek to understand all this stuff. Bluetooth stuff, it's also a huge change. Android work, to be honest, it's a very funny thing, but I don't know the details. For sure, there is also very new and important, I would say, API job scheduler, and you will see in a bit that it's not that hard. Also a part of Lollipop, right? If you go through all the changes, you can see that there is a list of API difference. There's a report in the Android documentation. There are lots of new packages there. The list goes on, and one random change there. It is a range new package, basically a range of two numbers, like 4 and 10. And if you look at the package there, you can see that it's not that complicated. It's just two numbers. You can check if a third number is within that range. You can check if two ranges overlap, and there are like 10 more methods there. And if you look at the code, it's like this. It's like 4 lines of Java, which is basically super easy to understand. And while I was reading the changes in the Android Lollipop, I was going through the code, and then when I saw that and this story, and I thought that okay, it's not that hard. It's something that I can make. I can write this code, and if it ends up in Android Lollipop, then it means that I'm at their level, right? At the level of guys from Google. So of course there are also the projects. Another thing that is very important for Google, and it's very easy to have this impositor syndrome because of this project. Why? Because the projects are in the Google materials on the web, in the blog post. Also, they are quite interesting. For instance, in Jelly Bean, the project Butter was about making your UI smoother. Huge task, I guess. Other project like with KitKat, or even something Google called Project Fee, so the telecom thing. There was also a project called Volta. We'll talk about that project here, but I think that it's important to say that when somebody asks you, what are you doing? Very often we developers are like this. I'm creating a new method, I just wrote a method, it's no big deal, nothing very important. I think that very smart is you call it a project, maybe even put it on GitHub. If we call it something a project, we are proud of that. And there is no reason for us to create, if you create a library just for ourselves, call it a project. Call it a project Volta, for instance. Put it on the internet. And then this is not that hard, and this is a way to cure your inferiority complex. So let's get back to the Project Volta. Project Volta, huge task. The idea of Project Volta is to improve the battery life at various levels, at the platform level, at developer level. At developer level, it means new APIs for us developers. Even at user level, there is, I think, battery saver and some tools for user to see what application is using more power and when the telephone will die, right? There is this chart showing how much juice is left in your device. So also, as part of this project, at the platform level, you have the art runtimes, huge project, not something a random guy from the internet can create. There is also a job scheduler. We'll talk about that in a minute. Also, battery saver. JobScheduler API. So once again, I was reading the code, trying to compare myself, and found this JobScheduler API, which is actually in Java. So all the code is on the internet, it's in Java, so I understand that, and I can read the code and make a few comments about that. And also, what's funny, the JobScheduler API is a part of very important Project Volta. So for me, it was like, if I understand the job scheduler, if I can say that I could write this job scheduler, then maybe it means that I'm a Rockstar developer, right? So let's look at the JobScheduler API, but before we look at the JobScheduler API, we need to understand what was it for, right? It's for a task. So we have an application and a task. It's wise for the task to be not user-facing, so a task that's doing something in the background. The same task is also, it's not given that the task will run at some particular point in time. So the task should be like, doesn't, the time of execution shouldn't matter for the task. And at the end, it could be, it's not requirement, but it's, the task could be like resource sensitive, like CPU power or something like that. So we have our task, right? Background task, like let's say syncing data from the server and storing it in local database on the device. In the old way, to run a task in the background, we can use sync adapter for that, or we can go with alarm manager, set alarm, let's say, do the sync every 3 hours, right? But when the alarm goes off, we have to make sure using, let's say, network manager, if we have the network, to connect to the server and get the data, right? So let's say we also don't want to do some heavy computing, so then it's wise to make sure that the charger is connected, right? So with the old way, we have to go through all the managers, and it's quite inconvenient because we have to set the alarm. If there is no network, we have to reset the alarm and check in 15 minutes, say, and if the network is available in 15 minutes or not, and it's not so easy. So that's why it's the JobScheduler API. With JobScheduler API, we have our task, which is basically an ID, an integer. We have service component, which basically is a service in our application. So when the time comes to execute the task, system will walk up our application, start the service, and say, service, please do the task number 4. We also can set some constraints. So for instance, we can say that we need a unmethored network for our task, unmethored network that will be Wi-Fi. We also can say that we require a charging. So basically, this is API of JobScheduler, a task that is a set of constraints, and at the end, we create a job info object. So we have our own app with a task. Then, thanks to the job builder, we create a job info object. So we converted the task to the job info. And then we have to schedule the task and send it to the job scheduler. So let's see how it works under the hood. First of all, what is the job scheduler? Job scheduler is a special beast. It's a system service. Of course, it's another reason why it's only available. The whole mechanism of system services only for Google. I mean, for guys who are creating their own Android builds. So it's not easy for us developers to create a system service. So job scheduler is a system service. Thanks to that, has some extra privileges. Let's see now what other services are available, system services. So we have battery service. This is a guy who can tell us what's the state of the battery, if the battery is charging or not. Another system service is a web view update service, which is super interesting and important from the security point of view, but also he's a guy who's listening for the action package replaced intent. So job scheduler system service, part of the core Android system. That's why it's only for Lollipop and works for Lollipop and this new release, Macadamian Nugget Cake. So we have our job. We send the job to the job scheduler, right? What happens next? First of all, the task can be persisted between reboots of the device. It wasn't true with the old approach. If we send an alarm, and then restart the device, the alarm is not set again when the device boots up, right? We have to use the onboard completed intent for that. So with job scheduler, if we have our task, convert into the job, and then send it to the job scheduler, what happens there, we can ask system to persist our jobs, and the whole process of persisting job is as easy as to write something into XML file. There is really no rocket science there. And the only thing that is not in our reach is that the folder is in the data system folder, so only available for platform developers. I mean, for applications that are running on with the certain privileges, so not for our own application. So, but the code is super simple. Just write the job into an XML file. Okay, so we have our job registered with the job scheduler. So how the job scheduler knows that it's time to run our task. So the job scheduler has so-called controllers. There are 4 of them. They are reporting the current state of the system. There is a network, battery, time, and one magical controller. So the controller is a code that reports the job scheduler where it's time to perform our task. Is it complicated or not? Could be, but it's not. For instance, the battery controller is basically, as we follow the red arrow on the top, basically it's a broadcast receiver. Broadcast receiver, it's a common component that each of us can write, right? It doesn't require any extra privileges. So battery controller is basically a broadcast receiver that on receive, so when time comes, gets a signal from the platform, and what happens? Well, the battery controller just registers for a bunch of intents, which are publicly available intents, like on battery low, on battery OK, connected, disconnected. And when the system is broadcasting the intent, the on-receive method kicks in. And then on next slide, I think, yeah, on the next slide, the battery controller is doing this dance with a bunch of ifs. It's a very simple code when the battery controller is checking if the battery is low. If the battery is low, then it's setting the battery health flag to false. If the battery is OK, it's sending the flag to true. There is, of course, some code is removed here, but it's mostly comments and debug stuff. The code is as simple as this. So the battery controller, basically a broadcast receiver with a bunch of ifs inside, simply code. What's very interesting, Google gave us a job scheduler only for Lollipop and app, and a random guy from the internet created a Compat version of the library. It was also for me a strong signal that maybe there is no magic there, maybe the code is quite obvious if a random guy from the internet created this. Of course, we know that there was a library called ActionBarShelock. It was also created by a random guy from the internet. In that case was Jake Wharton, that the library wasn't trivial at all. In this case, I must say the library is well done. It works like magic. It works like on new devices. The library is using the native API, and the older devices, I mean lesser than Lollipop, it's mimicking the behavior of job scheduler. What does it mean for us developers? It means that we can write an application using this API and doesn't be afraid to publish the application or have to rewrite the code. Okay, job scheduler for Lollipop and app. And for all the devices, let's create something based on Alarm Manager. So thanks to one guy from the internet and the fact that the code is quite simple, we have this Compat version, and let's see what's the difference. This is job scheduler from the Lollipop. So we have the central thing, job scheduler service in the middle. It's a system service. There are controllers on your right that are reporting to the job scheduler, and there are three applications. In this case, we have Google Plus app, Facebook, and let's say eBay applications. They are reporting, registering, scheduling jobs to the system service. This is a big picture of job scheduler in the action. How does the Compat version works? Very simple. Like I said, the only thing that the guy couldn't recreate was the job scheduler being a system service. So basically, each application has his own job scheduler service. It basically means that the whole stuff is, let's say, not as good in performance as the Google version, because each job scheduler requires more RAM because it's running in separate application. There is no common basket of all jobs, right? So this is the difference between Compat version, the version from Lollipop and the Compat version. The stuff in the middle, because it wasn't in the reach of the guy not working for Google and having chance to work with the platform. But Google fixed that, not by making a support version of job scheduler. They fixed that by doing something called GCM Network Manager, which is something super new from the Google I/O, and basically from it's part of Google Cloud Messaging version 3. How it works? It's not connected to the sending messages to the cloud messaging platform. In this way, it's not meant to send messages to the devices. It's a tool to register. In case of GCM, it's called task. In job schedule, there were jobs. Here we have tasks. If we compare the constraints we can set on the left are tasks, on the right tasks from GCM on the left, on the right jobs from job scheduler. If we compare the constraints we can use, the only difference is here that we cannot use this idle mode. We'll talk about the idle mode in a bit. The rest is very similar. I guess that the Google created this because the job scheduler API is not easy to use because it's only for Lollipop. So I guess that the usage is very low, and the guys from Google decided that let's do the thing in GCM. What's important here, the GCM is part of Google Play services. So it's available also on devices pre-Lollipop, right? This is another version that you can use to, this is a slide about this. So there are similarities here. So this is a tool we can use to use JobScheduler API on other devices than with Lollipop. But let's get back to the job scheduler. And I think that this is the most interesting part because, as you remember, there were 4 controllers. There are 4 controllers available for us: battery network, one more, charging. No, sorry, that's battery. 4 controllers. This is the 4th one, right? And this is the last controller that cured my inferiority complex. We'll see how the code works. But before we see how the code works, let's see what guys from Google will tell us about this mode, idle mode.
The next thing we introduce is idle mode. So this is, as it sounds like, a period of time for which the system has determined that the phone is not being used and is not likely to be used anytime soon. So just to take an example, if you set up a job that required idle mode and also charging, this would probably be executed sometime at night when the user is sleeping and the phone is plugged into the wall on their bedside table next to them. And from a battery perspective, I mean, you can't do much better than that. You know, you can hammer the CPU, you can do whatever you want. The user isn't around to see any of this stuff. And when they wake up in the morning, the battery's at 100% because it was plugged in all night. We've also consolidated a bunch of...
OK, so have you noticed that the guy on the left was laughing a bit at the end? No? Anyways, I can skip that. This is the idle mode, the 4th controller. System knows that the phone is not being used, and it's not likely to be used anytime soon. That's the quote from the video. My question is it create such an algorithm or not? The phone is not being used and is not likely to be used anytime soon. The phone, like in your pockets or in your bags, or this one here. How to tell that it's not being used? This part is quite easy, right? And it's not likely to be used anytime soon. Also, there is an example from the same video. If we ask the job scheduler, creating the job or the task from the new API, and creating the job, we say that we want the idle state and charging. From the video, it was said that it most probably will happen at night when the phone is next to your bed. Not easy, right? So let's say, before we go to the details, let's make one digression here. So with the Google, there is no one Google, right? There are many Googles because of their business and ads. They can target each of us differently, right? They understand my behavior on the internet, so I see different ads than you guys. They also understand many different things if it goes to the, let's say, money and ad-related business. Search, ad-related. I searched for Cristiano Ronaldo. That was said that was dumped by his current back then girlfriend Irina Shayk, I think. So on the left, a bit different result than on the right. Pictures are higher in the search results on the left, lower in the right, even if it's just one, let's say, one search result. Also at the bottom there are some let's say, follow-up searches, suggestions. They are a bit different. Another product, when all the power of Google is visible, also in the search, I searched for Nexus 6, and the first is an ad for a shop that's nearby the place I live. So it's only for me, right? It makes sense only for me. Another thing, it's also paid service. Google Play Music, there is a recommended for you section, right? With different kinds of music. So for me, it's Eric Clapton, that's good. So if it goes to money, Google is very good about, you know, making it targeted on each of us, right? So we are almost in the details. So we know that there is strong marketing of their technologies, and to be honest, as developers, we should be thankful for that because we have lots of videos, DevBytes videos. We can learn about their technologies. There are blog posts. They are very active also on Google+. There are some bold statements there in those videos, so it's quite funny. And if we see all those videos and those bold statements, we can think that there is a gap, big gap between us, mortal developers, and those rock stars from Google. And at the end, it is proven that Google is capable of doing really huge things, right? Let's say that with their ads business. So let's say how it works that the last controller, so-called idle state algorithm, or maybe idle state algorithm. First of all, let me explain the quotes here. So the quotes are actually not mine, they are in the code. If you follow the red arrow, quote is in the comment, and the code was written by a guy from Google. So I can imagine that the guy was writing the code, and for him it was like, it's idle. It's not idle, it's idle. But let's go and see if it's possible for the code to detect that the phone is not likely to be used and is lying next to my bed. So the idle state algorithm created, available in the job scheduler works like this. When the display turns off, just like in my phone, this timer is set for 71 minutes plus minus 5 minutes. 71 minutes. It's defined in the code, 71 minutes. Then, if the alarm goes off, we check. If the screen is still off, so the screen was off for 71 minutes, a bit more maybe, then we are in the idle state. If the screen is on, it means we are not in the idle state. So for me, if I press the power button, just see the time and turn off the display, the device is no longer in the idle mode, but of course, it's in the idle mode because I'm having a presentation. So I can imagine that if Google has my calendar, right? And I have a presentation, so I guess they could use that in the algorithm, right? Or are they using that? Not really. Let's see if I'm joking or not. No, so the code goes like this. The idle controller is the same as battery controller, so basically it's just a broadcast receiver. As required by broadcast receiver, there is an onReceive method. Inside this method, there is a bunch of ifs. They are checking if the screen goes off, basically by receiving the intent that the screen was turned off or the dreaming was started. So if the screen was turned off, they start an alarm, right? The third red arrow here. Next slide. This is a way to get out of the, to break the timer, right? So if the screen is turned on, they cancel the alarm so that the timer won't go off and they won't enable the idle mode. And the last thing here is, of course, when we receive after 71 minutes, more or less, the action trigger idle intent, we turn on the idle mode. So to look at this from the different perspective, time is not a factor in this case. I mean, time is a factor because we have those 71 minutes, but there is no way to say that it will happen at night. So it's not like at night, right? Next. Sensors are not being used, so it's hard to tell that the device will be lying next to my bed, right? Of course, there is something which is new, Android does. I guess I pronounced it correctly or not. There is another tool by Google to help with battery life. Maybe it's using sensor, but idle controller from Lollipop is not using. The only factor in the whole algorithm is the screen. Is it turned off or not? And what's let's say funny here is it's not tuned per user basis. I have a wear, and my wear was like, let's move around for 10 days, and I will learn how you exercise throughout the day, basically move throughout the day, and try to find the amount of steps you are making on average, so I can see if you are above or below the average. So with the wear, they are learning about my behavior. With the idle state, there is no such thing. There is this random 71 minutes here. So there will be a Q&A session at the end, but I was asked about the 71 minutes, if it's just random 71 minutes. I can imagine that it can be random 71 minutes because somebody thought that it's random 71 minutes, or maybe here is the whole power of Google. They are getting data from our devices. They made a query on their big database of data, and they come up with this 71 minutes thing. So here, maybe in this 71 minutes, is the whole magic of the whole algorithm. But then in the quotes, it was like idle. So the guy who was writing the code, he didn't have, I think, the information about 71 minutes because maybe there will be a comment. Now let's set it for 71 minutes because we have seen that it's the average of something. There is no clue in the code or the commit messages. So maybe here is answer. So my takeaways for you. One more thing about, for the 71 minutes. With the JobScheduler API, there is something called stable charging mode. So the stable charging mode, if you can imagine, it's when you connect your phone to the charger. If the charger is connected for more than 2 minutes, it means that your phone is in the stable charging mode. For me, it's also like, let's set some random timer and call it stable charging. It doesn't mean that it will be charging like for next 10 minutes, right? It only means that it's charging for 2 minutes. So this random 2 minutes, not a minute and a half or 2 minutes and 10 seconds, this 2 minutes and this 71 minutes here, for me is just a random number set in the code. At the end, my takeaway for you guys is as follows. Don't be afraid to look at the code. If you go to the developer Android.com, the get sources section, you will see that you need lots of space on your device to download. If you're using a Mac, you need a special partition because on Mac file system is not case sensitive, right? So it might be, you may have a feeling that it's hard to get the sources, but it's not that hard. You don't need like 10 gigabits of space. You can go to the GitHub and there you can download each package separately, and it's like the whole framework is, the whole Java of Android framework is like 20 megabits, something like that. So don't be afraid to look there. There is no rocket science there. And by looking at the code, you can cure yourself from various complexes. Another thing is don't be afraid to write code. Don't be afraid to call something a project, to put it on the GitHub, even if it's a crappy code, just like our code from the Barcap session, which I know doesn't work with Android 5.0 and up. It's only for Lollipop. It's awful C code there, but I'm not afraid to put code on the GitHub and to receive some even random comments from a stranger that it works or not. Anyways, write code, put it online, don't be afraid. And at the end, thanks a lot for DroidCon Berlin for inviting me and you guys here, and for you for attending my talk. Last question, because there are always questions, and maybe I will start with the question. So my question is it true that all of you know Kotlin? Because there is a Kotlin session on stage 1. Okay. So thank a lot for attending my talk and not the Kotlin session.